In this video, we're going to talk about our last section in this chapter, and we're going to talk about inferences from matched pairs. So what happens with this kind of data is we are dealing with dependent samples. There's some relationship that pairs each value with a value from the second sample. Examples of this would be before and after tests. You're testing siblings. You might be testing, for instance, let's say we were going to look at second graders, something about second graders, and we pair them by their reading score on a certain standardized test. And so what happens is the members we pick for the first sample influence the members we pick for the second sample. So you can think of this as they are purposefully paired. Now, one of the things that will never happen with matched pairs is the two samples will never have different numbers in them. They will always be paired, and if they're not paired, that's a good clue that it's a two-sample t-test rather than a matched pairs t-test. So now what happens with a matched pairs t-test is we look at the differences in those paired members of the two samples. So here's an example where we look at the height in centimeters of the president and the height in centimeters of their main opponent. So these are paired by presidential term. So they're very dependent. The members of the main opponent can't be in a different order than those of the president. They'll always be matched. And the key with these is we do not need to find the mean or the standard deviation of the individual samples. What we do is we actually calculate the differences and do all our data analysis on the differences. So a matched pairs t-test is actually a one sample t-test looking at the differences between the two individuals. This is usually a better sample than an independent sample. And part of that is because we reduce any variation that would be due to something else that we're not looking at, those lurking variables. We are going to use D to stand for the difference between the two values in the matched pairs. Mu sub D is going to be the mean value for the population of all matched pairs. This is going to be in our null hypothesis. D with a bar over it, we'll call it bar D, is the mean in our sample data, and S sub D is going to be the standard deviation from our sample data, and that's why we use a t-test. And then, as always, N stands for the number, but this time it's the number of pairs. The sample data must be dependent. The samples are simple random samples, and the number of pairs is either more than 30 or the population has a distribution that's approximately normal. And here is our test statistic, and it should look pretty familiar. We're going to take our mean, our sample mean of the differences, minus the hypothesized mean of the differences, which is usually 0. We're going to use the standard deviation of the differences and then the square root of n, which is the number of samples. Again, the degrees of freedom are n minus 1. The number of pairs minus 1. Now we're going to use StatCrunch to find our p-values exactly. If you don't have StatCrunch, you can use table A3 to find the range of values, or you can use a critical value method, but again, I recommend you use the p-value method since StatCrunch is so readily available to us. And when we do a confidence interval, here is our margin of error. So again, we're going to find the critical value as we have using the table. This is the standard deviation of our sample differences divided by the square root of n. The pattern should be starting to look a little familiar here. So we go back to our sample data, and step number 1 is going to be to calculate the differences. And then what we're going to do with that is we are going to do our data analysis only on the differences. We need to check that the samples are dependent and the values are truly paired. We need to know that those pairs are random, simple random samples, and because we have such a small sample set, we're going to check the normality and we're going to assume that that's met. Now this is a test, a graph of a test we haven't done to check for normality, so don't worry about that part. Here is our original claim, and the claim is that there is a mean difference greater than 0. So let's go back and see what that means. So the president minus the opponent is positive. So what we are looking at is the president is taller than their main opponent. If there's no difference in the individuals, then the mean difference will be 0. If the president is taller, then the mean of those differences will be positive. This is a one-tailed test. If we set alpha to 0.05, we're going to use the t-distribution, and here are summary statistics that we use StatCrunch to find. And then we're going to do a matched pairs t-test. So here's the mean of my differences, minus 0. That difference divided by the standard deviation divided by the square root of the number in the sample. So we get a t of 0.628. Our degrees of freedom are 4. And so now if we did our critical value, we would have set up our rejection region with 2.132 as the boundary, and our test statistic further in the distribution than that, so it is not in the rejection region. Our p-value is 0.282, which is not less than 0.05. And so, since our p-value is not less than 0.05, we fail to reject the null hypothesis. And your authors say there is not sufficient evidence to support the claim that for the population of heights of presidents and their main opponent, the differences have a mean greater than 0. Or we could say, this study suggests that presidents do not appear to be taller than their opponents. Okay, we can also do a confidence interval. When we do a confidence interval, that's always a two-tailed test. And so you can see our standard error is going to be more than 10. And so we take our mean minus our margin of error, our mean plus margin of error, and you can see here is the interval, and 0 is in the interval. So since 0 is in the interval, we have no evidence to support there's a difference between the height of the president and their main opponent. And that's what this slide says. What have we done? We've looked at what we need to do for matched pairs. We've looked at the notation. We've looked at hypothesis tests and confidence intervals, and now we're going to look at a few problems.